difference between classification and regression decision trees. So decision tree basically a machine learning algorithm where we used to make a model to train on a data set where we solve the problems like classification problem and regression problem by using the decision tree algorithm. So today we are going to talk about these decision tree algorithm and what is the difference between the main decision tree classification algorithm and the decision tree regression algorithm. So let's get into this. First of all, what are decision trees? If you strip it down to basics, decision tree algorithms are nothing but if else statements that can be used to predict a result based on a data. So basically, what we are going here is like we make a model, we pass our input data, and we expect that our model gives some output, and output in the sense like it gives us like predictions, something like that. So when we give our data, and let's say in our data we have some columns, and we in decision tree what we do, we make a tree like structure. As you can see on this left hand side, we make a tree, and let's say we are going to classify like if the person is survived or not in the Titanic boat, like, or as you all know, the some of peoples on Titanic will get die and some will get survive, so we have to predict who will get survived or who will get die. So here it's like a algorithm, a decision tree algorithm, where it's saying that a person is survived or not. So here it make an if and else statement based on your input. So is the sex is male or not, is the person is male or not. So if the person is not male, then there is like 36% chance or 0.73% chance that it is get survived, that the person is survived. And if not, like if the person is male and he its age is greater than 9.5, like he's an adult or adolescent, then there is more chance that he's get die. And if he is not, if the male person age is not greater than 0.5, then it's like is a really small born child or not. If the person is really small born child, like he's like his age is less than 2.5 there, then the chances that the person or that child will get survived is high. So as you can see from this decision tree, we just make some if and else statement using our data, and we make a tree and we predict that the person is survived or not. So let's move further. For instance, this is a simple decision tree that predicts whether a passenger on Titanic survived or not. Machine learning algorithms can be classified into two types: supervised and unsupervised. So machine learning algorithms are two type, we can classify them, we can divide them into two types like supervised and unsupervised. Supervised is like we have our input and we have also our output. Like if we provide our data, then we know that its output is like this and we train. But in unsupervised, it is like the output which is given by model is true, the and a model can give multiple outputs on multiple tuning, and all the outputs can be true. So here it's not like this is wrong and this is right, and here in supervised we know that this output is wrong and this output is right. Next is like a decision tree is supervised machine learning. This decision trees algorithm, uh, classification or regression, both are super comes under the supervised machine learning algorithm. It has a tree like structure, as you can see, a tree like structure with its roots node at the top. So here its root node as at the top, and here are some leaf nodes and other nodes. So this is all about the decision tree. Next, decision tree classification. So now we're going to talk about the decision tree classification algorithm, which is used to solve the problems of the classification. So for it is used to solve the classification problem, and a classification tree is an algorithm where the target variable is fixed or categorical. The algorithm is then used to identify the class within which a target variable would mostly likely fall. So basically here a classification tree algorithm is used to get the target variable with where the target variable is like fixed or categorical, like some states, number of states, yes or no, something like that. And it is used to identify that class, like categorical class. Like if I have four categories, one, two, and three, one, two, three, four, and that four categories are our classes. And decision tree classification algorithm is used to identify that class by giving our output. And it gives something like uh, deterministic, like it is gives the 100% surety that it is correctly wrong or right. An example of a classification type problem would be determined who will or who will not subscribe to a digital platform, or who will or will not graduate from high school. So it is like it is gives us the answer in yes or no or something like that. These are examples of simple binary classification. We have two classes, yes or no, so that's why it is called as binary classification, where the categorical dependent variable can assume only one of two mutually exclusive. So basically we have two categories, and at a particular time we have only correct one correct output. In the other cases you might have to predict among a number of different variables, and some other cases we have to predict some number in different cases. So next comes, like, for instance, you may have to predict which type of smartphone a consumer may decide to purchase. In such cases, there are multiple values for categorical dependent variable. Here's what classic classification trees look like. So here's like a tree where it is saying that this is this person is male, or this person or female. So this is like a classification tree. If the height is greater than 180, then we can say that the person is male. If the height is not greater than 180, then upon the factor of weight, we can say that if weight is greater than 80, then the person is male, or if the weight is not greater than 80, then we can say that the person is female. Now a student can ask me a question like, here sir, you are saying that if weight is greater than 80, then the person is male, but the female, there are also females who 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 weights the where her weights is greater than 80 kg. But this is a simple intuitive model to tell you about how a classification algorithm in its backend is look like. It is not all about these numbers, it is about the way how this classification problem is solved by using the decision tree classifier. So don't go on this number. When we gonna train our decision tree on the some data set, then it will give us some good value, a predictable value, where if we do the if and else condition, where we apply the condition and we go on a specific answer, then it will gives us the correct answer. Here it's like a fake data set. Then comes the decision tree regression, where we solve our regression problem by using this decision tree regression. Like where we want some values like 1 2 3 4, or well output as an integer. Then we can use this decision tree regression. A regression tree refers to an algorithm where the target variable is, and the algorithm is used to predict its value. So where we have to predict a value, then we gonna use this decision tree regression. And as an example of regression type problem, you may want to predict the selling prices of residential house, which is continuous dependent variable. So when we have continuous dependent variable, then we gonna use this decision tree regression, like something like we have to predict the price of house. And then at that time we gonna use this decision tree regression. This will depend on both continuous factors like square footage, as well as categorical factors like style of home, area in which the property is located, and so on. So these values depend on multiple factors, like the area, the where the house is built, the area where the house is situated, and other things like state, city, and some other factors. Next, regression tree for log salary. Like this regression tree is look like, if we go to this point, then we can say that the value is something around in between 0 and 0 5.0, and if we get here, then value is around something here, and if we get at a box, then a value can be around 7. So this is our regression tree look like. Next, when to use classification and regression tree. Classification trees are used when the dataset needs to be split into classes which belongs to the response variable, where we have to predict some response variable, like where we have only 2 or 3 classes, n number of classes, then we're gonna use this classification problem, decision tree classification. In other words, they are just two or mutually exclusive. In some cases, there are maybe more than 2 classes in which a case variant of the classification tree is used. Then the regression tree, on the other hand, are used when the response variable is continuous. For instance, if the response variable is something like price of a property or the temperature of the day, a regression tree is used where we have to predict a value. There we can use this regression trees. In other words, regression trees are used for prediction type problems, while the classification trees are used for classification type problems. So when we have to predict a value, we can use the regression trees. When we have to classify some classes, then we can use this classification algorithm. Then how classification and regression tree work. A classification tree splits the data based on homogeneity of data. Say, for instance, there are two variables, income and age, which determine whether or not a consumer will buy a particular kind of phone. If the training data shows that 95% of people who are older than 30 bought the phone, then the data split up and the age becomes the top node in the tree. This split makes the data 95% pure. Measures the impurity like entropy or Gini index are used to quantify the quantify the homogeneity of the data when it comes to the classification trees. So basically, when we say that a consumer will buy a particular kind of phone or not, then we can split our data. Then we can see that 90, if the 95% who are older than 30 bought the phone, then we can say that if the person is older than 30, then that person may buy this phone. Then there is 95% chance that this person will buy that phone. Next, in regression tree, a regression model is fit to the target variable using each of the independent variable. After this, the data is split as several points for each independent variable. At such point, the error between the predicted values and the actual values is squared to get a square is to get a sum of squared errors. So basically, in regression trees, a regression model is fit on a target variable. Like we have some numbers of range of target variables which are depend on the independent variables that we put on. And when we put on then when we give our independent variables, we get some range of target variables, and after that we split up the data into several points for each independent variables. Like for every independent variable, if when we get this independent variable, when we get some value for this independent variable, then we go to this point, and something like that we make things. And at each such point, the error between the when we get error between the predicted and the actual value, then the error is get squared, and we sum up all those errors to get to see the total error in our algorithm. The SSE, a sum of squared errors, is compared across the variables, and the variable or point which has the lowest SSE is chosen as the split point. So basically, on the factor with where the on the factor for which the SSE value is lowest among all the independent variable, that factor is chosen first, and that factor is chosen first and chosen as a root of our tree. This process is continued recursively, and these all points are recursively continuous till we get a depth of a tree, till we get a tree at according to the depth which we said while we applying this algorithm. Like when we have to apply, when we are going to implement this algorithm in Python or other languages, then we specify the maximum depth, and according to that depth, this uh, decision tree will make nodes up to that depth. So that's all about these regression trees, and that's all about the decision tree, where we talk about, first of all we talk about what are decision trees, like how this work, and what is going on in the back end, and how it's look like, what is basically a decision tree. Then we talk about the what is decision tree classification, that what is going on in the decision tree classification, what are the examples for that, how it's look like. Then we're gonna talk about the decision tree regression, why we gonna use this regression, decision tree regression, when we gonna use this, and we talk about like how it's look like and how it predict the value. Then we see that when we have to use these classification trees and regression trees, and how then we see that how classification trees and regression tree work at the back end, like how they make these graphs and all for the classification and regression trees. So that's all for the today's session, where we talk about the difference between classification and regression decision tree. And I hope I am able to clear your all doubts, and you will able to understand what is difference between classification and regression trees. So that's all for the today's session. Thank you. Bye bye. Take care. Stay motivated and keep learning. Today's session, we are going to talk about decision tree regression, where this decision tree regression is comes under the machine learning algorithm of decision tree, and it is this algorithm is used to solve the regression type problems, like where we have to predict some values or numbers like integers there to solves the problem like that like for an for an example, if you predict an house price or price or something, or weather or temperature, something like that, at that time you can use this regression decision tree regression algorithm. So let's start with this, and an overview of decision tree algorithm. Decision tree is one of the most commonly used practical approaches for supervised learning. Basically, this decision tree is used for supervised learning techniques, and it comes under the supervised learning. It can be used to solve both regression and classification tasks, with the latter being put more into practical application. And it is a tree structure classifier with the three types of nodes. The root node is the initial node which represents the entire sample and may get split further into the further nodes. The interior nodes represent the feature of a data, and the branches represent the decision rules. Finally, the leaf nodes represent the outcome. This algorithm is very useful for solving decision related problems. So basically, this decision tree algorithms makes a tree in its backend, and there are three types of nodes. The root node, which through which they it classify the it splits up the data, and the interior nodes which takes the decisions, and the leaves node which is the outcome of our decision tree algorithm. Next is divide and conquer. This decision tree algorithm use the divide and conquer technique to divide the data and tell the prediction. So basic divide and conquer algorithms select a test for root node, create branch for each possible outcome of the test, split instances into subsets, one for each branch extending from the node, repeat recursively for each branch using only instances that reach the branch, stop recursion for a branch if all its instances have the same class. So basically, it selects a root node by dividing the data sets. Then it's further dividing the then it further dividing the data set into the subsets in a recursive method met and till it met the condition, or it makes some instances. Till that time it recursively splits the data sets into the subsets and make nodes. So that's about the divide and conquer algorithm. This is how a tree looks like in decision tree: root node, interior nodes, and heap nodes. Next, regression tree. A regression tree refers to an algorithm where the target variable is and the algorithm is it used to predict its value. As an example of a regression track problem, you may want to predict the selling prices of a residential house, which is continuous dependent variable. So basically, a regression, this tree algorithm refers to algorithm where we have to predict some values like 1, 2, 3, 4, or some float type values. And for an example, if you are thinking like which values, then you can say like if you want to see get the prediction, or if you want to get the prediction for a residential house, like a continuous variable like 50 lakhs, 1 crores, or 1 million, billion, something like that, we have some continuous number values, then at that time we can use this regression trees for the outcome. And this will depend on both continuous and factors like square footage, as well as the categorical factors like the style of home, area in which the property is located on. So this regression output is basically depend on the very much factors, like many factors like the style of home, how the home is made, the area of home, like in how many square feet the houses, and the area in which the property is located, like in which area is good or not, or there is much crime or not in that area, or like how many number of bedrooms in there, or there are many more factors like sun facing balconies, the car garage facilities. So on that number of features, this outcome, this prediction of houses depend on that. So that's how this regression tree works. There we for the solving this regression type problems, we can use this decision tree regression algorithm. So this regression trees are used when the response variable is continuous. For instance, if the response variable is smooth, something like the price of property or the temperature of the day, a regression tree is used. In other words, regression trees are used for the prediction type problems, while the classification trees are used for the classification type problems. So that's about the regression trees, where we can use this regression trees and how we can use this. So this is how a regression tree looks like if condition is false, then it goes here, again condition if false, then it goes here, and there is a range of values, and according to that range of values it will predict or tell us a value for that. Like here is lower range, and here for A is higher range around 7, here 3 is lower range, like value is between the range of 3 around, and something like that. So according to that it will predict some values to us by this regression decision tree. So next, the advantages of this decision tree regression: inexpensive to construct. This don't take much computation power, extremely fast at classifying unknown records. So it is very fast, very fast to give the prediction, easy to interpret for small sized trees. So if we have a small sized trees, then it is easy to interpret about that tree. Accuracy comparable to other classification techniques for many simple data sets. So by comparing the data sets for the other by comparing these classification algorithm, we get a much more accuracy for simple datasets. By this decision tree algorithm excludes unimportant features. So this decision tree algorithm removes the unimportant features, discard the unimportant features from the dataset and take the only those features which are important. Consider only those features which are relevant or which are used to give the prediction in a correct or more accurate. So next comes the disadvantages of the decision tree regression. Easy to overfit. These decision tree are can easily be overfit to our dataset. Decision boundary restrict to being parallel to the attribute axis. These decision boundaries are restricted, and decision tree models are more often biased towards splitting on features, having a large number of levels. So basically, these decision trees are try to split up the data as much as they want and try to increase the depth of the tree. So that's why this decision tree is easily overfit. Small changes in the training data can result in large changes to the decision logics. So if you try to to change the data at small level, still that small change will result in the that small change will result in the large changes to the decision logic. Trees can be difficult to interpret, and the decisions they make may seem counterintuitive. So basically, if you make a decision tree with a large depth or higher depth, like 50 or 100, then it is difficult to interpret that decision tree and understand that decision tree. And this is the basic main disadvantage for this decision tree regression algorithm. So that's all for this coding session where we talk about the decision tree and overview of this decision tree algorithm, a divide and conquer technique which is used by this decision tree, and how this decision trees look like in its backend, and regression tree, how it is you work and why we use and where we can use like examples. Regression tree example like this, how decision tree regression is looks like, and advantages of this decision tree regression and the disadvantages of decision tree regression algorithm. So that's all for the theoretical session. So here I open my Spider IDE where we going to do our regression, decision tree regression algorithm implementation of this machine learning algorithms. And here, as you can see, I specify my path as Python code. There I make a subfolder regression tree, and here my Python file regression tree.py. So let's start with our implementation of decision tree regression. First of all, I'm gonna import some basic libraries which we can use, may or may not be. So now here I upload importing the load Boston dataset. For that I import the load underscore Boston function, and I get my dataset, and from there I get the feature matrix and the target variable, which you can say the target vector. And then I import train test split function from the model selection module in the sklearn library to divide my dataset into train and test set. Now I import the minmax scalar class, make an object of it so that I can normalize my data in between the range of 0 and 1, and I normalize my training data, test data, and whole data set. Now I import my decision tree regressor class from the tree module in sklearn library, and make an object of it having the maximum depth 5, and I think I increased that to 10. And I make object for decision tree regressor class having maximum depth 10. And now I'm gonna fit my model on the training dataset. Now let's see score on the training dataset, test dataset, and the score on the whole dataset. So I get the training accuracy 99%, test accuracy is 54%, which is low, and the accuracy on whole dataset is 92%. So now let's do some prediction. I get my prediction. Now let's see the accuracy R2 square for this. So print the R2 square value. My R2 square value is 54, which is very high. And let make the tree. This is my tree, like having maximum depth. This is the structure of my tree. As you can see, tree is very high, so it go beyond the total view. So this tree is very high. So if you want to see the whole tree, you have to minimize the depth. So let me minimize the depth at 5. Fit the data, score, prediction, to square, and let me print the. Now I get a small tree having depth 5. So this is how my tree looks like. Like if features less than 6.5, then it goes here. Otherwise, it goes to here. So this is how decision tree regression tree or backend tree is look like. So let me plot it and show it to you. So where is it? This is my decision tree, and if you want to see more it in, if you want to see it in a more good way, then what you can do, like here I save this PNG file. Here I save this plot in the format of PNG file, and you can open that file in the in the regression tree subfolder, and there you can see that tree. And that's all for the today's session, where I tell you that how you can implement this decision tree regressor, and there you can see the score and other things also. So that's all for the today's session, and I like to say that you just import some other data sets too. Try to import some other data set and try to train this model, fit this model on that data sets too, and get the prediction, get the accuracy on the test data set and other things like R2 square value, and try to plot the model. It will increase your skills and it will good for you. So that's all for the today's session. Thank you. Bye bye. Take care. Stay motivated and keep learning. So for the classification, this decision tree classification algorithm implementation in Python, I'm using the Spider IDE, where I in the Python course folder, I just make a classification tree folder, and there I make a classification tree Python file. And in this Python file, where we are going to do our coding session for for implementation of decision tree classification algorithm in machine learning. So first of all, I'm importing the basic libraries, NumPy, Pandas, Matplotlib as NP, PD, and PLT respectively. Now I'm loading the wine dataset, where I'm saying the quality of wine, and let me get the x and feature data x and the target variable y. Here we have some classes for this wine, and we have to predict which wine is it. So I just import the feature matrix and the target vector. Now let me import the train test split function for dividing our data set into train set and test set. And now we get training set and testing set. And here I am normalizing our data, training data and testing data. And here I import the decision tree classifier class, and I make an object of it with the maximum depth 10. And here I fit my model for the training dataset. Now for the training dataset, I fit my model. Now let's see the accuracy on the training dataset, accuracy on test dataset, and the accuracy on the whole dataset. So that's the accuracy, and as you can see, we get accuracy less on the testing dataset because we get overfit on our training dataset. So now let's do some prediction on the test dataset, and let's see some how this test is looks like. Let's see some precision of it, recalls, one score, and classification report and confusion matrix. To see the confusion matrix, here I print the confusion matrix for this wine classification. This is the score, precision, recall, F1 score, classification report on the test data sets. And now let me create the this classification, decision tree classification. This is a tree for the, this is our tree for 10, for the depth 10, and let me import, let me plot this in a beautiful way. Yeah, this is our decision tree, and it is also get saved in the directory. So if you want to see this in future, then by using this tlt.savefig function, I just saved my file in the name of image name, in the name of this image name dot png in the in the classification tree folder, subfolder. So that's all about the today's session, where we're going to talk about the classification tree and its implementation. So that's all for the today's session. Thank you. Bye bye. Take care. Stay motivated and keep learning. Today's session, we are going to talk about the decision tree classification. So here we are going to talk about basically the decision tree algorithm, which is used to classify the, which is used to solve the classification problem when we have, so when we have to predict like categorical variables like 1 2 3, or classes like, or some boolean value, let's say yes or no, true or false, where we can say that binary classification, only two classes we have at that time, we are going to use this decision tree classification. So we are going to talk about this decision tree classification algorithm in our today's session. So let's start with this. Below is an example of classification tree where the outcome was a variable like fit or unfit. Here the decision variable is categorical or discrete. Such a tree is built through a process known as binary recursive partitioning. This is an iterative process of splitting the data into partitions and then splitting it up further on the other on each of the branches. So basically, here we make a classification tree where we specifying that here the variable is like fit or unfit, male or female, on the basis of some features. So this is a basic like basic classification model which we have make on the based on some data. And don't see like if the weight is greater than 80 kg, then we are saying that the person is male, and you are saying that females are also there whose whose weight is also greater than 80. But here I just show you an intuition that how a classification algorithm makes a tree. Decision tree classification makes a tree in its backend. So it is on a fake data, not a real data. So that's how decision tree classification makes a tree, and this is a dummy tree. Next, we go to the creation of decision tree. In this method, a set of training examples is broken down into smaller and smaller subsets, while at the same time an associated decision tree get incrementally developed. At the end of the learning process, a decision tree covering the data set is returned. So basically, when we have a n number of training examples, they all are broken down into smaller and smaller subsets, and they are associated associated in decision tree get incrementally, and they all get incrementally developed. And at the end of learning process, we get our model, which is a decision tree model. The key idea is to use a decision tree to partition the data space into clusters or dense regions and empty or sparse regions. In decision tree classifier, in decision tree classification, a new example is classified by submitting it to a series of tests that determine the class label of example. So basically, new example is just determined by the class label that when we in the decision tree, when we have to classify an example, then on the basis of that arguments or conditions, we classify that. These tests are organized in hierarchical structure called a decision tree. Decision tree follows divide and conquer algorithm. Decision tree are built using heuristic called recursive partitioning. This approach is almost commonly known as divide and conquer because it splits the data into subsets. which are then split repeatedly into even smaller subsets, and so on and so forth until the process stops when the algorithm determines the data within the subsets are sufficiently homogeneous and another stopping criteria has been met. So basically, it is using divide and conquer technique, which is dividing our data and splitting our data into subsets. And this is done by recursively partitioning recursive method. And here we divide the subsets. We divide the subsets into smaller and smaller units till we get a particular output, till we get a leaf node, or we meet a criteria. Till we are breaking down our subsets and making some conditions on it. And next, what is divide and conquer? Basically, divide and conquer algorithm select a test for root node, create a branch for each possible outcome of the test. Next, splits instances into subsets, one of one for each branch extending from the node. Repeat recursively for each branch using only instances that reach the branch. Stop recursion for a branch if all its instances have the same class. So that's the meaning of the divide and conquer, where we divide the uh, data, split the test for the root, create branches from that subsets, splits in instances into the subsets recursively till we getting the same class or meta condition. So that's how a divide and conquer technique is implemented. And decision tree classifier, using the decision tree algorithm, we start at the tree root and split the data on the features that result in the largest information gain ig. On the basis of the largest information gain ig, we select our root node. In an iterative process, we can then split this splitting procedure at each child node until the leaves are pure. This means that the samples at each leaf node are belong to the same class, and in practice we may set a limit on the depth of the tree to prevent overfitting. We compromise on purity here somewhat, as final leaves may still have some impurity. So basically, trees is divide is made in such a way that leaf node has a leaf all leaf nodes has same class. Till then a decision tree is till then a decision tree is made. But here's a thing, like, to prevent this decision tree classifier model to get overfit, we specify a depth so that it doesn't get overfit. So it has some impurity in its leaf nodes, like all the leaf nodes are not belonging to the same class. So advantages of decision tree classification: inexpensive to construct, extremely fast at classifying unknown records, easy to interpret for small sized trees, accuracy comparable to other classification techniques for many simple data sets, excludes unimportant features. So basically, it is extremely fast, easy to interpret, and easy to understand, and accuracies also we get a good accuracy for a small data set, and it leaves the unimportant undesired features from the data set. So that's all the advantages of the decision tree classification. And disadvantages of decision tree classification are easy to overfit. It is easily get overfit on our training data set. Decision boundary is strict to being parallel to the attribute access. Decision tree models are often biased towards splits on features having a large number of levels. Like, the decision tree are restricted to being parallel to attribute access, and the it is get biased on the training data set. Small changes in the training data can result in large changes to the decision logic. Large tree can be difficult to interpret, and the decisions they make may seem counterintuitive. So that's all are the disadvantages for the decision tree classification. And that's all for the theoretical session, where we talk about the more in depth about the decision tree classification, that how the tree is make, and how tree is created, and how we get served from the data, that how data is served and how prediction is get make, and what is decision tree advantages of it, disadvantages of it. So that's all for the today's theoretical session.
Cluster analysis in R. Cluster analysis, it is unsupervised machine learning technique which helps to find hidden patterns in raw data, and there is no dependent response required in this type of machine learning technique. It is used for grouping similar objects. So clusters are created based upon similarity of the object, wherein the clusters are homogeneous within. They are based upon the similarities and they are heterogeneous with other clusters. So each cluster will be homogeneous with the objects present in that cluster, and it will be heterogeneous with the other clusters. So for example, if a company want to group customers based upon different preferences, buying patterns, or buying potential of customers, so they are trying to determine the appropriate audience for the product. So using clustering algorithm on customer base, what they will do is they will sell products to the right customer base. So this is how cluster analysis helps to group the objects based upon their similarities. For example, a simple example has been taken to create clusters. Here there are different students and their marks are given like subjects of physics and mathematics. So there are student PQR, they have similar marks in physics and mathematics. Then XYZ students, they have similar pattern of the marks, and ABC students have a similar pattern of marks in both the subjects. So if the clusters will be created, so you can see there are three clusters created, similarity in their marks, and they are heterogeneous with the other clusters that have been created. So some of the applications of cluster analysis are, first of which is marketing. So in marketing, customers are clustered as per the potential of the buyer. So the potential buying pattern or the potential buyer for a product or service, a company generally cluster the customers based on that. Then there is retail. So in retail, grouping of customers are based upon their preferences, their choice of buying pattern, their style, their economic background. Then there is medical sciences. Medical sciences, it facilitates efficient diagnosis, treatment of
In
patients.
today's session, we are going to talk about the hierarchical and non-hierarchical clustering techniques. So let's start with this hierarchical and non-hierarchical clustering techniques. And first of all, we talk about the hierarchical clustering. Hierarchical clustering is basically an unsupervised clustering technique which involves creating clusters in the predefined order. So basically, this hierarchical clustering basically comes under the supervised learning techniques. It is comes under the supervised unsupervised learning techniques, and which involves the creating of clusters. It creates the clusters by using some predefined order. The clustering are ordered in a top to bottom manner. In this type of clustering, similar clusters are grouped together and are arranged in a hierarchical manner. So basically, some similar clusters are together and are arranged in an hierarchical manner so that we can get some clusters as number of as we want. It can be further divided into two types, mainly agglomerative hierarchical clustering and divisive hierarchical clustering. So basically there are two types of clustering, agglomerative and the divisive. And in this clustering we link the pairs of clusters. All the data objects are there in the hierarchy, so we try to put the clusters, pair of clusters, all the data objects in an hierarchy format to find out the clusters. So, a hierarchical clustering method produces a classification in which small clusters of very similar molecules are nested within large clusters of less closely related molecules. So, basically, a hierarchical clustering method produces a classification like there the small clusters of very similar molecules are nested, like small clusters are combined to make a large cluster of less closely related molecules. Hierarchical cluster methods are tend to be very demanding of computational resources, typically or is to power n square for n compounds, since a complete hierarchy of partition has to be built up rather than just a single partition. So basically, these hierarchical methods are used very computational power. They use very much computational resources like about typically or is to power n square, which is big O notation for n compounds, and be- it is because of it has to make a complete hierarchy of partitions to be built up. So rather than the just single partition, it it is making a complete hierarchy, which takes much computation resources. One problem with these methods is how to choose which clusters or partition to extract from the hierarchy, since display of full hierarchy is not really appropriate for datasets of more than few hundred compounds. So basically, when we are talk about it's when we see the hierarchical algorithm, we see that it is difficult to understand that how many clusters do we make from that data set, because the hierarchy is because the seeing the hierarchy and find out the appropriate for the data set is very difficult for that. So it is much difficult to find out the number of clusters from the hierarchy by seeing the hierarchy. And this is like hierarchical clustering. Like agglomerative is like making small clusters, and we keep on increasing and make a hierarchical cluster. Divisive means like we put a full cluster and divide them in small clusters. So that's about the hierarchical clustering. And next is like non-hierarchical clustering. Non-hierarchical clustering involves formation of new clusters by merging or splitting the clusters. It does not follow a tree-like structure like hierarchical clustering. This technique groups the data in order to maximize or minimize some evaluation criteria. So basically, like hierarchical clustering, this non-hierarchical clustering technique doesn't make any hierarchy, and this technique is group the data in order to maximize and minimize some evaluation according to some criteria. It is used to maximize that or minimize that. K-means clustering is an effective way of non-hierarchical clustering. K-means clustering algorithm is come under the this non-hierarchical clustering. It is an effective way of non-hierarchical clustering technique. In this method, the partitions are made such that the non-overlapping groups having no hierarchical relationship between themselves. So that's about it, the non-hierarchical. And there are also points like a non-hierarchical method generates a classification by partitioning a dataset, giving a set of generally non-overlapping groups having no hierarchical relationship between them. So non-hierarchical method basically classify a partition of data set given giving a set which are non-overlapping, having no relationship between the two clusters. Like if I say that I have two clusters, then those two clusters are different from each other. A systematic evaluation of all possible partitions is quite infeasible, and many different heuris- heuristics have been described to allow the identification of good but possibly suboptimal partitions. So the systematic evaluation like of possible partition of quite infeasible. Like if we have a large number of data points, then the evaluation of possible partition is like quite difficult for that. And thus, the it has been described to allow the identification of good but possibly suboptimal partition. Three of the main categories of non-hierarchical method are single pass reallocation and nearest neighbors. Nearest neighbors methods such as the Jarvis-Patrick method assign compounds to the same cluster as some number of their nearest neighbors. User-defined parameters determine how many nearest neighbors need to be considered, and the necessary level of similarity between nearest neighbors list. Other non-hierarchical methods are generally inappropriate for use on large, high-dimensional datasets such as those used in chemical applications. So basically, in this non-hierarchical, we try to make the clusters by using nearest neighbors and by the user input. Like if I have to make the 5 clusters, then by using some nearest neighbors technique we make clusters on that. And the non-hierarchical methods, some of the non-hierarchical methods are inappropriate, then that means the non-hierarchical methods can't be used on the large or very high dimensional data sets, such as if we are using on the chemical applications where the data set is very large, we can't use this non-hierarchical clustering methods. So this is like a non-hierarchical clustering method where we cluster the group on the basis of the nearer point. Like this is a single cluster according to their nearer point. These blue points are single cluster. These is another cluster. These orange are the another cluster based on the similar points. So that's about the clustering and non-hierarchical clustering. And next is the, I just make a some chart of this table of the difference between hierarchical clustering and the non-hierarchical clustering. So hierarchical clustering involves creating clusters in a predefined order from top to bottom. Non-hierarchical clustering involves formation of new clusters by merging or splitting the clusters instead of following a hierarchical order. It is considered less reliable than non-hierarchical clustering. It is comparatively more reliable than hierarchical clustering. So basically, non this hierarchical clustering is not much reliable, but the non-hierarchical clustering is much reliable. It is considered slower than the non-hierarchical clustering. It is comparatively more faster than the hierarchical clustering. So basically, we are making a hierarchy in the back end of the hierarchical clustering. So that's why this hierarchical clustering is slow, and the non-hierarchical clustering is comparatively much faster than the hierarchical clustering, because there is no competition and there is no hierarchical graph in its backend. It is very problematic to apply this technique when we have data with high level of error. If we have some, like, if we have some outliers in our data or some error in our data, then it is very problematic to implement this hierarchical clustering. And this non-hierarchical clustering can be better than the hierarchical clustering even when the error is there. So there is, in the non-hierarchical clustering, we can also use this if there is any level of error in our data. It is comparatively easier to read and understand, and we can easily read this hierarchical clustering and understand the hierarchical clustering. The clusters are different to read and understand as compared to the hierarchical clustering. It is relatively unstable than the non-hierarchical clustering. It is relatively stable technique. So this hierarchical clustering technique is not much stable as compared to the hierarchical clustering. It is unstable, and the non-hierarchical clustering technique is basically much stable as compared to the hierarchical clustering technique. So that's all for this hierarchical clustering. Like in this hierarchical and non-hierarchical clustering, we talk about first first what is hierarchical clustering, where we make a hierarchy in its backend and do some operations. And there are namely two types of hierarchical clustering: agglomerative and hierarchical clustering, and the divisive hierarchical clustering. And we used to link the pairs clusters on the objects in and form a hierarchy. And it is very it is it uses very high computational resources, and this is what a hierarchy cluster looks like. And after this, then we came to the non-hierarchical clustering, where in non-hierarchical clusterings we don't make any hierarchy in its backend, and its criteria is based on some it has some criterias, it has some like equations or some formats according to which we have to minimize some criterias or maximize some criterias to get the clusters, to get the required clusters. And the k-means clustering is one of the effective algorithm is comes under this non-hierarchical clustering, and it makes the non-overlapping groups. And we talk about much more about it, like what is non-hierarchical clustering. And after that, this is our non-hierarchical clustering look like, where we don't make any hierarchy in its backend, rather than we are considering the similar points, the points which are closer to each other, which are nearest to each other. Then we discuss our then we discuss the difference between hierarchical clustering and the non-hierarchical clustering So that's all for the today's session, and I just suggest you that you just do more R&D, research and development on this hierarchical and non-hierarchical clustering, and try to figure out what is. I just tell you about the basics and more than the basics, but I want you that you read some research papers also, so it will give you more intuitions about more clear picture about this hierarchical and non-hierarchical clustering. So that's all for the today's session. Thank you, bye, take care, stay motivated and keep learning.
Hierarchical clustering. Now, hierarchical clustering, when we do hierarchical clustering, we understood that it is a nested clustering wherein different clusters are created and it goes as a nested because the values with least distance it binds together, then it goes in a form of tree like structure which is called as dendrogram. So when we are doing hierarchical clustering, it is also done on numerical values only. So we are taking three columns: age, annual income, and spending score. And also we know that hierarchical clustering is better when the data set is small. So I'm taking only 10 values, only 10 records here for analysis. You can do it on your whole data set also, but you should understand it with small data set first. So let's just subset our data set. Let me show you how it looks like. So this is the data set that we are using. There are 10 rows and 3 columns. Now let's scale this. So whenever you are doing hierarchical clustering, you should scale your data set in order to create good structure of your dendrogram. So using scale function, we will scale this data. If you want to check how it looks like, so it is data. So this is our structure now. This is our data set. The average age is 28, average annual income is $17,000, and spending score is 49.4. Now you can see each of the attribute, each of the variable, it is in the same scale. Now the next step is very important to understand when we are doing hierarchical structuring. Hierarchical clustering, it uses the distance method. We need to calculate distance of each of the clusters. So for that, the function is dist, which helps you to find out the distance. Now, if you remember, we have done the similarities between two clusters. We read about this. So when we use the single linkage algorithm, so it finds out the shortest distance in the both of the clusters, or any cluster, that how many clusters you are using, it will find the shortest distance. When you are using complete linkage algorithm, it will calculate the longest distance between the clusters. If you are using average linkage, so each of the points of each clusters, the distance will be calculated between each of the points. And when you are using the centroid method, distance between centroids, so the distance will be calculated for the centers of each point. Now let's go to R and create, let's first calculate the distance. So it is also called as distance matrix. Let's print this. So these are what happens, like the first value, it will be compared to the second value. So, and distance will be calculated between those points. Then the second value will be compared to the third value. First value will be compared to all the values. Then second value will be compared to the remaining values. So this is how our distance matrix looks like. Now you can see our first point, it is and second point, the distance between these 2 points is 1.2059. Then the distance between 1 and 3 is 1.157. So you can see the distance between 1 and 3 is less than distance between 1 and 2. So if we create a dendrogram, 1 and 3 point, the observation 1 and 3, it will be grouped together. So this is how a dendrogram is created. Points that have least distance between them, they will be first bundled together, then it will be creating a tree-like structure. So let's go ahead and create the hierarchical cluster. For that, the function is hclust. So it will create hierarchical clustering. Within the bracket, give the dataset name. So I am using here the scaled dataset. So remember to use the dataset that is scaled, and then we'll say plot hc, that is the hclust function. So you can see this is the cluster dendrogram that we have got from our dataset. You can see the matrix here, distance matrix, and this is its dendrogram. Now let's understand it. So you can see 1 and 3. As I have told you, the distance between 1 and 3 is less than 1 and 2. So if I take 1, so 1 and 3 are the closest one. So they have been clubbed together. So these are the initial clubs. You can say initial clusters. Then you can compare 4 and 6. So 4 and 6. So it has the least distance. So they have been clubbed together. Now, so this is our first clusters that are nearest to each other. Now, if we are take 2 and 4, 6. So how this cluster is created? So we have talked about two types of hierarchical clustering. So there is agglomerative and divisive. So if we take agglomerative, it goes down to top. So starting from bottom one, the clusters will be created and will go to top to one cluster. So let's go like that first. Let's go in agglomerative way. Now you can check, like it is said, we can see 2 is more near to the group, that is 4 and 6. So how do we compare it? Why isn't it near 1 and 3? Let's check it. So 2, if we compare it with 3, okay, so we are comparing it with 3, so the distance is 2.24. And if I compare it with 1, it is 1.20. Okay, but if I check it with 4, so 2 and 4, so this is the value, it is 0.69. It is a very less distance. Then if I compare it with 2 and 6, the value is 1.35. So you can see this cluster we have already created 4 and 6. So 2 is much more near to this value. So the next cluster that have been created is 2 with 4 and 6 cluster. Now this is one cluster here. At this level, this was the cluster. Once 2 is connected with this cluster, so it became one cluster now. Now it goes ahead when we depending upon the distance, it connects this cluster and this whole cluster. So this is how it is a nested cluster. It ends when there only one cluster is left with us. So this is how you can check the tree-like structure that we were talking about. Now, once we have created dendrogram, it's time to get clusters out of it. So if you want to cut it into two groups, so the function that we use is cut tree. Okay, it's cut tree, and within the bracket you give the name of the variable wherein you have saved your function, your hierarchical clustering function, and here k means the number of clusters. So I want two clusters out of it. So let's see what happens. So there will be no change in the graph because we have not plotted it. We have only cut the function, the clusters, these groups, we have just cut it and saved it in subgroups. Now let's just use table command to check the values. Now these two clusters, first clusters contain 9 values, 9 observations, and second cluster contains only one value. So what does it mean? When we cut it into two, okay, if you can see in the graph, so here one value is entirely single value, and here these are 9 values. So all these 9 values clubbed together, it becomes one cluster, and this is the second cluster. Okay, if you can make out from this table, this is the structure of that dendrogram. It is the second cluster and this is the first cluster, wherein 9 values are available in first cluster and one value is available in second cluster. Now let's move ahead. Now what we can do is, when we do not mention anything in our function, we have used hclust here. but we have not given the method, like how the distance should be calculated. So here it defaults take it as average. So it has on default calculates the distance based on average linkage. So if I take average here, you can change it to complete or single, or there are different types of methods you can use. Just question mark it. You can always question mark hclust. We'll get here. So help is provided. So when we are saying method, so you can see there are different methods. There is what D, what D2, single, complete, average. So these are all different types of method you can use for your distance, calculating your distance. When I am saying average, so here average means it will calculate the distance of each point in each group. Now use this function in hclust. So hclust within the bracket the scaled dataset and method equal to average within the inverted commas. Now let's check this method and plot it. So for plotting, I am saying hang equal to -1. So what will happen is all the values, they will be in one line. Like if you check the earlier graph, there are different heights, right? 9 is here, 1 is here. So they were at different height. If I say hang equal to -1, so they will be at one level. And CEX, it will give you the font size of the values present in the graph. So it is 0.8, and main, it is the title of the graph. Inside plot, give the function name first, the variable containing your hierarchical clustering function, and then the different parameters. So let's execute it. So you can see it is the same, the values are same if we take, because it is the default method that was used. If we do not mention average here as a method, then also it will follow the average method only. If you take it as complete, let's change it. I'll just copy this function from here and let's change the method to complete and plot it. So you can see the groups has been, there is a difference. You can see the placing has been changed and even the height is changed. Let's see for the average one. So you can see the height is changed. Earlier height is in the form of proportions here, because it is in the form of averages. Now if I take it as complete, y-axis values are also changed. So let's make it average itself. Now we want to cut the clusters out of this graph. For that, the function we are using here is rect.hclust. So it will cut the clusters in a rectangular form. So there are two ways you can cut the graph, or you can say you can make the clusters. So you can use K form or H form. So K is the number of clusters and H, it is the height, okay, based upon the height. So height here, it means it follows the level at which your distances are calculated. So if I say I want two clusters to be created, and border here means the color of the border. So the color of border, it will take from 2 to 4. So it is the default numbers that are given to the colors. Like if I just select this, run this command, so you can see there are two clusters that have been created. So in first cluster, the border is green, and the second cluster is in red color. So in first cluster, there are 9 values, and in second cluster, there is only one value, as we have already discussed. So if I say make it 3, I want 3 clusters. So the height will be changed. Let me show you again. If I say I want 3 clusters, so you see the height is changed here. It has moved a little below, and it has cut where we can create 3 clusters. So now in first cluster, there is only one value. Second cluster, there is 2 values, and remaining all the values, they have been allotted to third cluster. So this is how you can create, cut your tree using K as a value, that is number of clusters. Now if you want to do it using height, where you were giving K, you just say rect.hclust within the bracket, the function variable, and then the height equal to 1.5. So I want to cut the graph at 1.5. Let's see what happens. So it is the distance. So here we have got 1, 2, 3, 4, 5 clusters. So this is how you can cut your tree using using rect.edgeclust command. And AB line will draw a line to show you the height. Like if you want what is the mean of this tree, like that, so you can just give a line there. So I want at distance or height equal to 3, just give a line there. So this is how you can create a line at your graph. So this is one cut. So this is how you can create k-means clustering, hierarchical clustering, and do the scaling of your data set. An example has been taken here for cluster creation, where different student group of students is given and their marks of physics and mathematics is given. So there are three groups in this data set. So you can see there is PQR student. They all three have similar kind of marks in both the subjects. Similarly, XYZ and ABC, they have similar kind of marks in both the subjects. So if we create cluster for this data set, we have three groups wherein PQR is in one group, XYZ is in one group, and ABC is one group. So this is how cluster will be created, wherein each cluster will be homogeneous within and heterogeneous with the other cluster. Then there are few applications given here which are you wherein the cluster analysis is used in those domains. So first is marketing. Customers are clustered as per their potential buying pattern based upon the product and services. So in marketing companies, they group the customers based upon their buying patterns or buying behavior and their economic statuses. So this is how a marketing company uses cluster analysis for a product or service. For retail market, they generally group the customers based upon the age group, or you can say the choice of their buying pattern or the style of the customers. So these are different factors which can be taken in order to group the buyers. Then there is medical science. So medical science use cluster analysis to facilitate efficient diagnosis or treatment of patients. So you can see whenever we go to a hospital, a particular kind of treatment, they have different floors for it. So they have grouped different treatments together on different floors. So this is how cluster analysis can be done for medical sciences. Then there is city planning. So city planning, it can be taken as an example like grouping houses according to the house types or the geographic nature of that area. So there also cluster analysis can be used. Then there is sociology. So sociology, dividing people based on their demographics, their lifestyle or socio-economic factors. So there are also a cluster analysis can be used. Then there are two approaches for clustering. So first is hierarchical clustering. Hierarchical clustering, it is a nested cluster wherein progressively nests are created. Nests here means clusters. So each cluster starting from a small group, it gets into a larger cluster and stops when one cluster remains. You can see in the example here, the first pattern, the first layer here, they are the initial clusters that have been created. Then joining them, a bigger cluster is created, and at the end there is a single cluster left. So this is how a nested cluster or hierarchical clustering is done. Then hierarchical clustering is generally used for small data sets. Small data sets here, it can be taken as less than 100. It is more it gives more good outcome when the data set is small, because there are chances of overfitting the data set in hierarchical clustering. Hierarchical clustering, when you run the algorithm in your program, it is generally slow, it has slow runtime for the algorithms. Then the outcome of the clustering, hierarchical clustering, is a dendrogram. So the graph you can see here, it is called as dendrogram. Then the other approach is k-means clustering. K-means clustering, it divides n objects into n number of clusters. So what does it mean is there is a defined number of clusters wherein the whole data set has to be divided. It is good to be used for large data sets because we can create a defined number of clusters for the large data set. So the runtime of this algorithm, k-means algorithm, is faster in comparison to hierarchical clustering. Then what do we do in k-means clustering? We find centroids, or we can say the average of the data set, and based upon those centroids, we create clusters. So the points nearing to that uh, centroid, those points will be clustered in one group. So this is how different clusters are created. So the optimal number of clusters in k-means clustering is found by using elbow method, which we will be doing when we will be working upon the codes of clustering. Then k-means clustering is always used for the continuous variables. Then there are two types of hierarchical clustering. So it is agglomerative and divisive. So agglomerative, it works upon bottom to top approach, and divisive, it goes top to bottom. So what does it mean? Like in this graph also you can see the agglomerative will go from the least, the first clustering layer to the last, the wherein the whole data set becomes one cluster. And divisive, it means starting from the first, that is the top layer, wherein the whole data set is taken and it is divided into small clusters. So this is how two of types of hierarchical clustering are there. Then we need to find the similarities between two clusters. So there are different kind of linkages that are used to find the similarity between two clusters. So first is the min, or you can say single linkage algorithm, wherein the shortest distance between the points in each cluster is calculated. So you can see there is a cluster 1 and cluster 2. So the shortest distance will be calculated in order to find the single linkage algorithm. Then there is complete linkage algorithm, wherein we calculate or find the longest distance between 2 points in each cluster. Then there is group average, or you can say average linkage hierarchical clustering. So it is used, these similarity or linkages are used when we are using hierarchical clustering algorithms. So average linkage hierarchical clustering is done by calculating or the distance between each point in one cluster to every point in the other cluster. As you can see in the image also, the distance is calculated with each of the point in both the clusters. Then there is one more distance, that is you can say the similarity that can be find out by using distance between the centroids. So centroids will be computed for cluster 1 and cluster 2, and uh, then similarities between the two centroids will be checked, and that is how the clusters will be divided. Then it is very important to understand distance measure of clusters. So distance measure is calculated for hierarchical clustering and k-means clustering. There are two ways we can find the distance. It can be done using Euclidean distance or Manhattan distance. So Euclidean distance, it is the straight line distance. As you can see in the image also, it is a straight line distance. It is also called as Pythagoras matrix, wherein you can see there is a graph here. So it computes the square root of the sum of the squares of differences between corresponding values. So as in we used to calculate Pythagoras theorem. So we will be calculating the hypotenuse of this triangle. So it will take a 5 minus 1 points. Here you can see it is 1 1, and at point 2 it is 5 and 4. So the distance will be calculated as 5 minus 1 whole square plus 4 minus 1 whole square and its square root. So it is a Pythagoras theorem wherein we are calculating the hypotenuse of this triangle, and it will be the Euclidean distance for clusters. So each cluster has a centroid. So if we are talking about clusters now, so we have discussed how to calculate Euclidean distance. And if we talk about clusters, so each cluster has a centroid, that is average of the clusters, all the points. So measure of each cluster distance will be calculated for each of the cluster. So this is how Euclidean distance will be calculated. Then there is Manhattan distance. So Manhattan distance, it is also known as city block or L1 norm, wherein it measures distance along the axes of right angle. So why is it called as Manhattan distance? It calculates the distance that will be traveled along the coordinates only. It will measure the distance by the right angle of each of the triangles. It captures the distance between 2 points by aggregating the pairwise absolute difference between each variable. So as you can see in the example also, it does not take the square of the values. It takes the absolute value for the distance calculation. So if we take what happens is Euclidean distance, it will exaggerate that discrepancy. So discrepancy here means if there are scattered points near the centroids, so it will exaggerate the discrepancy that will be calculated in the distance. But if we are calculating Manhattan distance, it will shrug it off, being more influenced by the closeness of other variables. So this matrix is less affected by the outliers of Euclidean.